I'm coming at this, my technical expertise is in meta-analysis, so taking the results from multiple studies, sticking them together to inform policy. And I've been doing that for a long time, and it goes wrong for a lot of reasons, and some of those reasons might be informative for us to think about. So that's where I'm going to start. So one meta-analysis that I was involved in was looking at marine protected areas. So I've got a nice picture of some cod. Do marine protected areas work? And I was told by I was a postdoc at the time, I was told by my PA, Gav, go and do your technical stuff on the meta-analysis. We want to know whether marine protected areas work. And I did. And we found out there were more fish inside marine protected areas than outside marine protected areas. Great. How does that? And I was thinking, oh, well, that's wonderful, and I was waiting for, all the fantastic policy impact to come along, and it didn't. And I was like, why? What's gone wrong here? What's happened? And I twigged that we were just asking completely the wrong question. Where is the decision context for that question? The decision facing a decision maker isn't how many fish are there in a marine protected area. The decision is, where do I put them? How many do I have? What other things might I do other than having marine protected areas to protect fish stock? Yeah, so I had the wrong comparators. Okay? And so that really kind of highlighted to me that if you're interested in informing a decision, the first thing you need to do is to really understand what the decision is. What are the proposed interventions? What are we going to do? What are the comparators or the counterfactuals that we've been talking about? What's the decision context? And again, we talked a little bit about this at close of play yesterday, but it struck me that we're diving in to what does our system model look like, what should be in it, how are we going to handle spatial and temporal scaling? And we're not spending enough time thinking about what are the decisions that we're trying to inform. So that's an example of meta-analysis going wrong because the scientists got it wrong. Here's an example of meta-analysis going wrong because the policymakers got it wrong. So this is one that I did on habitat corridors. And this was for DEFRA. And I was all excited and I bounced along going, well, hey, DEFRA want to know about habitat corridors. And I went into the stakeholder meeting at the beginning. And I said, so, you want to know, what do you want to know about habitat corridors? You want to know if they work. What do you mean by habitat corridors working? This is like what Bill was talking about what is biodiversity. Now, what aspects of work are you interested in? What's a meaningful effect size? And I got a horrendous answer, which was, you guys tendered for it, you won the tender, that's your problem, go away and figure it out. Right? I knew at that point I could write a really nice scientific paper and I could spend the next 6 months of my life doing a meta-analysis, but whatever it was going to do, it wasn't going to bloody well inform policy. Okay, so this question definition stuff is a real double act. It needs the scientists to get it right, and we sometimes get it wrong, and it needs the policy world to engage and to learn, and they sometimes get it wrong. Okay, but we neglect this at our peril. We can do the most beautiful mathematical models in the world. They will, unless we get this right, they'll be absolutely useless. So even though it's, a bit undergrady, get the right question, it's really, really important as well. It's not easy. Okay, the policy timelines are against you sometimes. There might be secrecy. The policies might change, not as if we're in a particularly stable political environment at the moment. They might not be known. It's easy to say, here's DEFRA's 25-year plan. Wonderful. What are you actually going to do? Oh, well, you tell us that. Yeah? But if I turn around and say, oh, well, I'm going to establish an anarcho-syndicalist collection of statisticians and mathematical modelers, I'll be told, oh, no, we're not interested in that. So they won't tell me what they do want, but they know some of the things they don't want. So this can be challenging. You can have misalignment with the science agenda. Okay, we've been talking about data quite a lot of the time. What you want is just really nice, good, solid monitoring data. the kind of old school stuff that we used to do. You know, it's not sexy science. It's not gonna, it's not gonna light everybody's bells, but it's what's needed. What happens if I cut down these trees? What happens to the flood risk? You try getting a primary study like that funded. Forget it. It's not, where's the Nature paper in that? But if you want to parameterize a model about flood risk, that's the data you really want. Yeah? So there's misalignment with the science agenda. And then funding processes. I was going to stick an ass up here and give you the joke about the Bayesian who thinks he sees a horse, but then spots a donkey in the next field and he gets an ass. And then you've got the front end and the back end of the ass. And the front end problem with this is that if you're going to build a decision model with this and you're going to have this discussion about exactly what is the decision, this takes a lot of time, energy and effort. Okay, and that time, energy and effort needs to be funded. Okay, so we shortcut it when we write the grant and then it's a bit wrong. But then we're tied into it and we've got our work packages defined and off we go and do it, and there's a bit of wiggle room and we use our Weasley words. But basically we don't have a good decision making context because we didn't have time at the beginning and it wasn't funded at the beginning to do it. Yeah? And then we end up at the back end with the problems because we promised the Earth to get the money. We're worried about looking crap because we failed to deliver on promising the Earth, unsurprisingly. So we get all excited about our pathway to impact and everything, yeah? And then you end up doing this, how good is half a fish from your marine protected area thing. And then you start moaning about how the policymakers don't understand quants. No, we've got the process wrong. You wouldn't need to worry about explaining how good is half a fish if you'd got the decision right at the beginning and had that co-production. So there's something a bit wrong with how we're doing our funding, if anybody from NERC is listening. Right, so you've got your question now, so the next thing is the uncertainty in that question. Does the uncertainty matter? Right, so now I'm a little bit further on in my postdocing career. Now I'm all excited about needing decision models. And we've got to do decision models, and we need decision models, and we need decision models under uncertainty. And I'm working with this guy here who's Joseph Lau. Joseph's a bit of an unsung hero in the evidence-based medicine movement. He's done an awful lot of really hardcore cool stuff. And I was visiting him and bouncing around being all excited about my newfound ideas about systems models. And he kind of said, I'm paraphrasing here, chill your jets, Gav. Cool down, mate. If I've got a meta-analysis and it tells me that A is better than B, there might be all sorts of uncertainty, but all other things being equal, A is better than B. What are you going to do? We think drug A is better than drug B. Which drug do you want? Drug A. All other things being equal. So sometimes the uncertainty doesn't actually matter. And we don't need to worry about propagating the uncertainty everywhere. Then sometimes it gets a little bit harder. What if A might be much better than B, but it might not work at all? So this is dead common. Okay, so this is the situation where we're doing what we do, our standard normal practice. It works, but it doesn't work spectacularly well. So when someone comes along with a new thing, we go, oh, this is brilliant, we should do this new thing. But it's new, so the science isn't very well evolved, so the confidence intervals on whether this thing works or not are massive. So we've got a new thing that might be better than the current thing, but it might also not work at all. What do you do? Now suddenly it depends on whether or not you're more interested in maximising your gain or minimising your risk. Yeah, and there's a minimax, and there's all sorts of different frameworks for thinking about that in decision theory. You got a problem. You can still probably figure it out if you can combine a couple of probabilities in your head. Most of us can't. Have you seen the papers about the medics doing this with diagnostic tests? So if you go to the doctor and they give you the result of a test to say, yes, you have geek syndrome. We know that you've got a 99% probability of having geek syndrome because your test result from a test that has got a 99% sensitivity says positive, you are a geek. Yeah, but you need to combine that with the probability of, given that I'm walked in from the general population, what's the proportion of in the general population of geeks? That's a very low probability. So it's increased your probability massively that I've had that positive test, but it's nowhere near 99%. Yeah, and the medics get that wrong all the time. So you might be able to figure this out, but actually we're pretty crap at doing maths, and even combining two probabilities is sometimes beyond us. Let's make it a bit more complicated. What if A is better than B, but there's a small risk of a catastrophic event with A compared to the moderate risk of a trivial event with B? This is still pretty simple, yeah, but it's starting to get a bit more realistic. And again, you might think about those trade-offs, you know, and you know, you can think about the way we think about the small risk of a catastrophic event, something like a nuclear power station blowing up. We take that kind of thing very, very seriously. We regulate very heavily. Or a moderate risk of a trivial event. Don't want to over-trivialize it, but you might think about something like air pollution there. We're concerned about the number of qualities that you generate for air pollution. When you add them all up, it's huge, because air pollution affects a lot of people, but for each individual person you're talking about a couple of weeks of their life. So that's the example where, you know, the risk is pretty trivial, but it's the fact that there's an awful lot of it that means that you care about it. So you just care about those in different ways. Right. So those first couple, you might argue you can get away without a decision model to do the math. Now we've got a whole alphabet, because we're where we are, yeah? So we've got different uncertainties, we've got multiple outcomes. What if they're all linked by uncertain temporal and spatial autocorrelations? Well, they are. We just heard about that. They've got non-linearities and tipping points in them. Well, we don't know where they are, but we know that they're there. We're going to go across social, biological and physical systems. So we're all talking different languages. We need absolutely loads and loads of data. It's going to get very complicated very, very quickly. And we're where we were yesterday with the herendogram or the Harrisonogram. Yeah? And we have to make some kind of a choice about how we handle this. And we're on this spectrum from intractable complexity to unrealistic simplicity that we all come across all the time. Yeah? And we have to make a load of value judgments about what we're going to do. And what I'm saying is when we make those value judgments, we should be thinking about it from the decision-making perspective, not from the science perspective. We shouldn't be doing what's interesting for science or what our pet project is, or what, you know, we should be trying to simplify that from the decision perspective. And that's where it gets difficult to generalize, because we can pull all of this data together and we could look at it for afforestation. You could go, half of this data is really, really important and interesting for this next decision, but you would need a slightly different model with slightly different bits in it. So this is the challenge that I think we have, is how do we kind of develop a system that lets you properly address individual decision questions, but then lets you kind of build on it and go across to the other ones. Okay. But I'll be arguing for this needs-led rational decision theoretic model. Okay. And what do I mean by that? All I mean is that you have the value of the event, the thing that you're interested in, your outcome, and you times the probability of occurrence. So you have some kind of a model that's probabilistic in that sense. I share Henry's concerns about this cost-benefit analysis. But effectively, my interpretation of it is that's the whole natural capital system. I kind of see this as something where this is where the decision makers have told me this is how they want to do it. You know, at the end of the day, the Treasury Green Book, if something has an implication for UK PLC of 5 million, they care about it. If it doesn't, they don't. And so you can almost argue it the other way round. You can argue if ecologists and the environmental sector don't get on board with this stuff and do it well, then we're always going to get kicked in comparison to the other disciplines and the developers who are using this system. How many minutes? Oh gosh, I'm going to have to speed up. Right. What can I miss? I'm trying not to be precious about how we do this. There's all sorts of different ways that we could do this. This decision model would probably be, I'll probably see it as being an object-orientated model at the bottom of some kind of a big system where you've got your process-based models, your agent-based models, Bayesian networks. It doesn't need to kind of propagate across the lot. Lots of advocacy not routinely applied. Really nice thing about this is we've talked briefly about updating. This, if you can develop a framework like this, even if it's a bit crap to start off with, as new data comes in or new insights come in, you change it, you update it, it's transparent. Yeah. And you can prioritize future research really nicely with this, because you've got the uncertainties in there. You can effectively say, if I take parameter A and reduce the uncertainty to 0, how does it change the decision? If I take parameter B and reduce it to 0, how does it change the decision? So you can prioritize, oh, I need to know about parameter B, not parameter A, because that has more of an impact on my decision. Okay? So it provides a really rational way of deciding what the research priorities are, rather than relying on a bunch of experts, us, when we know that experts get it wrong as often as they get it right. Not that I'm bitter about having all my grants rejected. If you want to read about this stuff, Cambridge scientist, appropriate to say, Dennis Lindley, this book, Understanding Uncertainty, is one of my all-time favourite books. It is absolutely brilliant. Everyone who's involved in this should be reading this book if they haven't already. Right, I'm going to speed up, so I'm not going to show the clip. It's time to walk the walk on model uncertainty. Yeah, we talk the talk all the time. Let's stop talking, start walking. We know a lot of this stuff. If you're thinking about, if you're saying we want to think about uncertainty, how? We need to agree what's acceptable here. Do we need full explicit probability distributions? In which case we're Bayesian. Sorry guys if you're not. Or is it okay to kind of, wave our arms around in the air, or is there something in between that we're happy with? Similarly with model structure, do we need full reversible jump MCMC type approaches, in which case we're Bayesian? Is the scenario analysis enough? Is the one-way sensitivities that we talked about this morning enough? Some vague mumbling in response to review or two, take your pick, but we need to kind of figure out where we are on this, yeah? Oops, I just pressed the wrong button, that was clever. This is probably the stuff I can really skip through. Just a word of caution about big data and getting all excited and chucking all of these parameters together, and I kind of felt a little bit uncomfortable with a couple of the talks about natural capital yesterday. It's like, yeah, okay, you're giving me a single figure for this. Where are the confidence intervals on that figure? Where's the uncertainty? Just because things are correlated, well, so what? We need causal inference engines in there. We need counterfactuals. Yeah, we need to be being a bit careful about parameterizing these things and the data sources that we use. Expert elicitation, technical field in its own right, because there aren't many social scientists, just to say that sometimes you might be better off eliciting the opinions of the right person whose n equals 1 than asking lots of the wrong people. So it's a very different way of thinking about the world from a natural scientist. So again, if we're going to try and say what's acceptable, how do we make these value judgments, and how do we do this in a repeatable way? Most published research is wrong. This is all my meta-analysis stuff. If you want to know about the meta-analysis stuff, talk to me later. But basically, if you pick up a paper in a journal, it's probably bollocks. Okay, I know you guys have written a lot of them, so have I. We've got the p-hacking, harking, publication bias. Every bit of meta-science that comes out on this goes, yeah, it's happening in your field too. Yeah, it's really big. Yes, it's a real problem. We need the open science stuff. From what I'd argue for this is that if we're going to parameterize these models with stuff, it needs to be parameterized by meta-analysis, or at least critically appraised evidence. We need to think about what's going into the models, and that's it. Time to walk the walk. Thank you.